This is Mrs.Abisha Baslin, Assistant Professor AAA, Analyzer JJ College of Engineering. Now I am going to taking the subject about control system. Introduction of control system. A control system is a combination of components connected to perform a required action. Consists of subsystems and process plants assembled for the purpose of controlling the outputs of the processes. Provides an output or response for a given input or stimulus. A control system is an interconnection of components forming a system configuration that would provide a desired output in response to input signals. They guide and control space vehicles, aircraft, ships, and high-speed ground transportation systems. Modern automation of a plant involves components such as sensors, instruments, computers, and applications of techniques that involve data processing and control. It is essential to understand a system and its characteristics with the help of a model before creating a model control for it. The process of developing a model is known as modeling. Physical systems are modeled by applying notable laws that governs their behavior. For example, mechanical systems are described by Newton's law and electrical systems are described by Ohm's law. The classifications of control systems depending on the hierarchy: open loop control system, closed loop control system, optimal control system, adaptive control system, learning control system. Depending on the presence of human being, manually control system, automatic control system. Depending on the presence of feedback control, open loop control system, closed loop control system. According to the main purpose, position control systems, velocity control systems, process control systems, temperature control systems, traffic control systems. Feedback control systems, linear and nonlinear control systems, time varying systems or time invariant control systems, a continuous data control systems and discrete data control systems. AC mode, AC or DC control system, position control, traffic control, process or velocity control systems. First order, second order, underdamped, critically damped and overdamped systems. Open loop control system. In recent years, control systems have gained an increasingly importance in the development and advancement of the modern civilization and technology. Disregard the complexity of the system. It consists of an input, the control system and its output. Partially, our day-to-day activities are affected by some type of control systems. There are two main branches of control systems. One is open loop control system and closed loop control system. Now we are going to see the open loop control system. The control system that cannot adjust itself to the changes is called open loop control system. In general, manual control systems are open loop systems. The control system circuit diagram is shown in the figure. In this, the R of T is the input signal in the control system. The output signal in this system, the output remains unaltered for a constant input. In case of any discrepancy, the input system should be manually changed by an operator. An open loop control system is suited when there is tolerance for fluctuation in the system and when the system parameter variations can be handled irrespective of the environmental conditions. The output signal of the open loop control system is not feedback to influence the control actions. The control action of the open loop control system depends only on the input signal. Open loops are not capable of filtering disturbance or noises. Open loops are suitable when input signals for satisfactory system performance can be estimated, approximated and does not change. The advantage of an open loop control system is compared to closed loop is cheaper to build. The advantage of open loop control system: simple design. The physical layout is straightforward with fewer parts, make it very easy to build and set up. Low cost because it does not use feedback sensors or complex parts. It is cheap to make and fix. Fast response. It reacts quickly to commands because it does not have to wait to check or measure the output. High stability. It is naturally stable and does not get stuck in shaking or looping errors caused by feedback. Easy maintenance. Fewer parts mean fewer things can break or need repairs. Disadvantage of open loop system: no feedback mechanism. The system does not check the final output, meaning it cannot automatically detect or fix errors, low accuracy, and reliability because it relies completely on preset inputs. Any change in the environment leads to wrong result. Sensitive to disturbance, external changes, or load variations directly ruin performance since the system cannot adjust itself. Requires manual tuning. Workers must step in and fix or recalibrate the machine by hand but wear out over time. Not flexible, it cannot adapt safely to sudden changes or complex unpredictable tasks. Closed loop control systems. The output signal of closed loop feedback to influence the control's action and improve the overall system performance. Examples: robot arms, velocity control systems, temperature control systems. However, in practical, a combination of both open loop and closed loop is normally used. For example, washing machine, the process of filling up the tank with water. Any system that can respond to the changes and make corrections by itself is known as the closed loop control system. No, only differences when compared to open loop system is the presence of feedback action. The block diagram of closed loop system is shown in the figure. Advantage of closed loop system: high accuracy. Feedback allows the system to compare the target goal with the actual result, reducing errors and providing precise control. Automatic error correction. The system fixes problem on its own when outside changes or disturbance happen. Resilience to variations. It works well even if system parts wear out or environmental conditions change. Reduced noise sensitivity. The feedback mechanism minimizes the impact of external noise and load disturbance of the final output. Support automation. It enables complex automated tasks without needing a person to constantly check and adjust settings. Disadvantage of closed loop systems: high cost. They need extra parts like sensors, detectors, and motors, which make them expensive to build and fix. Complex design. Setting them up takes a lot of careful engineer work and computer programming to get the settings right. Risk of instability. The feedback loop can make the system to go out of control, cause unwanted shaking or bouncing if not done well. Slower response. They take extra time to take the output and make changes, which can slow down how fast the system reacts. Sensor dependence. If a sensor breaks or gives wrong data, the whole system will make bad choices and fail. Difference between open loop and closed loop control system. Open loop control system and closed loop control system. In open loop control system, easy to design and build, and the closed loop control system, design and constructions are more complex. In open loop, performance depends on proper calibration. Closed loop performance improves due to feedback. Generally more stable, comparatively less stable. Optimization for desired output cannot be performed in open loop. Optimization can be done very easily in closed loop control system. Feedback mechanism is not present in open loop. Feedback mechanism is present in closed loop control system. Requires less maintenance in open loop. Maintenance is difficult in closed loop system, less reliable in changing conditions in open loop, more reliable due to automatic corrections in closed loop. In open loop control system operates comparatively slower. In closed loop control system operates faster and responds quickly. In open loop control system, installation is simple and economical. In closed loop control system, installation is complex and expensive. Thank you.